Inverter.
Hi, welcome to clickmyproject.com. This video will lead us to the complete demo of Center-Initiated Decentralized Dynamic Load Balancing for Multi-Cluster Computational Grid Environment. Load leveling is critical for economical utilization of resources and enhancing the performance of machine grid. Job migration is good thanks to dynamically balancing the load among multiple clusters in the grid surrounding. Due to restricted capability of single cluster, every cluster saves the data regarding its neighbors, as well as the transfer delay obtainable between the native resource and its neighbor, and also the load price of its neighbor. Problem in multiple cluster load leveling primarily based on job migration across separate clusters. A decentralized grid model as a group of clusters for machine grid surrounding is planned. A center-initiated decentralized dynamic load leveling algorithm rule is introduced. So this algorithm rule estimates system parameters like the resource process rate, load on every resource. So balancing the load by migrating jobs to the least loaded neighbor. The resource by taking under consideration of transfer delay. The most goal of the planned algorithmic rule is to enhance the average response times of jobs. The planned algorithmic rule has been verified through the GridSim simulation toolkit and compare with non-migration algorithm rule. Simulation results show that the planned algorithmic rule yields higher performance compared with the NM algorithmic rule. So this will help us to migrating the job in the grid environment that will reduce the job execution time and reduce the fault tolerance rate. Next we are going to see the complete flow of center-initiated decentralized dynamic load balancing for multi-cluster computational grid environment. For this one, first we need to create a grid environment by using the grid resources, grid jobs and the grid information server. Next we need to create a grid users who are going to be submit the jobs, and we need to clustering these grid resources to some groups. Next we need to find the neighbors resources for each clusters to share their jobs and migrating their jobs. So allocation of the gridlet to resources will help us to executing the job. Next we must need to compute the current workload for the each resources on the time of job submission. So if the load will be greater than 0.9 means, that is the resource having the higher load means, we have moved to job migration. For this one, resource will be migrated to the nearby node. So for this one, first allocate the job to the neighbor node who having the lesser level of load. If the load will be lesser than 0.9 or the allocated job to the neighbor node means the job submitted to the particular resource. So next the job will be executed and the output will be gathered by using the grid information server. Next we are going to see the complete demo of center-initiated decentralized dynamic load balancing for multi-cluster computational grid environment. For this one, first we need to create a grid environment. To create a grid environment, we must need to provide the number of resources, number of users and the number of jobs. For this one, first I have to provide the number of resources as 8 to create the number of resources, and I have to provide the number of users as 5, and I have to provide the number of jobs as 20. Next we are going to create a grid environment. After that we creating a grid environment, we just move to create the users and formulate the cluster. So first I am going to be formulate the cluster, and also I have to move to the next level. So the clustering group will contain the individual resource ID and their name and their processing power, and also by the group IDs. So this processing power will be categorized by using the cluster formation. Next we going to be select the grouping the cluster. So here I have to collect the cluster groups and I have to formulate the neighbor selection. This neighbor selection will help us to migrating the jobs from one resource to the another resource. Here we have to developing the sum of the neighbor clusters based on the transmission delay. So each and every cluster group transmission delay will be shown. Next we need to create a grid information server for executing these jobs. Grid information server will collect all the resource details presented in the grid environment. It also collects the gridlet jobs and the user details from the grid environment. Next we create a grid jobs. So in this one we have to create a gridlets for individual users. For example, user 1 creating a 2 gridlets with their unique IDs. Next we move to the next level. So for this one we'll be executing the job for each and every user. The cluster movement process will move the clusters from one cluster to another cluster based on the resource ID if they necessary means. For example, here the cluster 1 resource 18 will be moved from the same cluster because there is no job available in the process. The simulation result will be gathered from the grid sim. The grid sim will return the original simulation results. Here we execute all the jobs by using the grid sim simulator. The simulator will help us to create the gridlets, users and resources and executing the gridlet jobs. It will reduce the computational time for each and every grid jobs. So the final results will show the gridlet ID and the status and the resource ID and the starting ending duration of the resource time execution. By using this process we have to reduce the computational time and we have to allocate the job to the less load process to achieve the fault tolerance concept. Thanks for watching.